Flight certainly isn't easy. Every beat of a bird's wing cuts through invisible currents of endless complexity. The air isn't just empty space, it's a wild mess of pressure and velocity. The challenge of flight gave rise to the science of aerodynamics, the study of how air moves around objects. A key focus of aerodynamics is understanding the behavior of airfoils, a streamlined shape designed to generate lift when moved through a fluid like air or water, basically a cross-section of a wing or blade. In this video, I'll explain a simple method for how one can simulate flow around an airfoil. Let's start by asking, what would be the simplest shape to simulate flow around? I'd imagine the answer to be a circle. The flow around a circle can be given by the complex potential W of z or its derivative W prime of z. The term I gamma over 2 pi ln z minus z naught controls circulation. We can remove that for simplicity. Now what W prime of z does is that it takes a complex argument z and returns the velocity vector of the flow at that position. This is enough information to simulate flow around a circle. But how do we use this to simulate flow around an airfoil? Is there any way to transform this flow around a circle to that around an airfoil? It actually is. Look at this transformation z plus 1 over z. It changes the circle into an airfoil. Let's look at this more closely. Watch what happens when we trace out the path of a circle on the normal complex plane to that of our transformed plane, our z-plane and zeta plane. The circle becomes an airfoil. This is enough to convert our flow around a circle to flow around an airfoil. To find the velocity vector of a point around our airfoil, we simply have to look at the corresponding point in the z-plane, the flow around the circle. We can solve for this z-coordinate by using the quadratic formula. Multiply by z on all sides, rearrange the terms, and use the quadratic formula where a equals 1, b equals negative zeta, and c equals 1. Finding the velocity vector of our point next to the airfoil is just a matter of converting the velocity from the circle. We can do this with the equation above. And boom! Now we have all the components we need to simulate airflow around an airfoil. I didn't mention everything you could do with the simulation though. You could change the circulation, or even change the shape of the airfoil. You could use a Karman-Trefts airfoil, or a symmetric Joukowski airfoil. If you have any questions, feel free to ask them in the comments. And if you enjoyed the video, I would highly appreciate if you considered subscribing.